Yes, good morning children. Acid radicals we will be discussing. In your practicals, you have to find out the acid radical and the basic radical in the given salt, and in this group today I will be discussing chloride. It is in the second group of acid radicals, and the reagent which is used to test the identification of chloride is concentrated sulfuric acid. If a given salt is there and you have to find out whether it contains acid radical of first group or second group, the reagent used is sulfuric acid. Dilute sulfuric acid for the first group and concentrated sulfuric acid for the second group, and chloride, bromide, iodide, they belong to the second group of acid radicals, and for them the reagent used is concentrated sulfuric acid. The method will be like this: you take the salt, you add dilute sulfuric acid, no change, you throw the solution, again take the salt, add concentrated sulfuric acid and warm if required. If any kind of gas comes out, that indicates that given radical is of your second group. Now discussing the individual test for chloride, it is like this. This is the salt which contains chloride. It is reacted with concentrated sulfuric acid, and either in cold or in warm you will find that some pungent smelling gas comes out, and that pungent smelling gas is of HCl. Again, if a rod dipped in ammonium chloride is brought near the mouth of the test tube, you will find that white fumes of ammonium chloride are formed. These two tests, they become the preliminary test. After this, a confirmatory test is done to confirm the presence of chloride. This is known as chromyl chloride test. This is the confirmatory test for identification of chloride, in which this is the salt 1 part, 3 part potassium dichromate, it is a orange colored solid. Then to it concentrated sulfuric acid is added, and you will find either in cold or on warming orange colored vapors, they come out, and these vapors, they are of chromyl chloride. That is why the test is named as chromyl chloride test. The formula is CrO2Cl2. It is very important to remember the formula of this orange colored gas. And then in another test tube you will take NaOH solution in which this orange colored gas is mixed. You will get Na2CrO4, that is sodium chromate, and then you will add lead acetate and acetic acid. You will get yellow PPT, and this yellow PPT is of lead chromate. So, formation of this yellow PPT, that is lead chromate, confirms the presence of chloride in the given salt. Now children, we will demonstrate it how the test actually happens. Let us see. Yes children, you can see now in the test tube we have taken the salt containing chloride, and to it the first step will be addition of dilute sulfuric acid to see if there is any change, and we will find that there is no change. We will throw the solution and we will take the salt again. First we will clean the test tube, and now we will add the salt, a pinch of the salt, not very much, in the test tube, and we will add concentrated sulfuric acid and just see what change occurs. Yes children, you can see you can see the pungent gas coming out, and it confirms, nearly confirms that this radical is of second group, whose reagent is concentrated sulfuric acid. So, as I have discussed you, the pungent vapors, they are of HCl, and now a rod dipped in ammonium, we bring near the test tube and you get white fumes of ammonium chloride. आपने एक rod ammonia में dip करी and we bring it near the test tube, mouth of the test tube, and white vapors, they increase. It shows that chloride is present. Now we will do one more confirmatory test, which is known as chromyl chloride test, children, and in this we will require orange colored solid. You can see it, it is placed here, it is orange colored solid, which is known as potassium dichromate. We have taken the salt 1 part in the test tube, and we will add 3 parts solid potassium dichromate in the test tube, and now we will add concentrated sulfuric acid to this mixture. We can hold the test tube with the test tube stand. We are adding concentrated sulfuric acid, and you will see brown vapors. They are brown vapors, they are deposited on the sides of the test tube, and these brown vapors, they are of CrO2 Cl2, that is chromyl chloride. Now we will keep another test tube ready which contains NaOH solution, and these vapors, they are allowed to pass through NaOH solution. We will pass these vapors in NaOH solution. These vapors are pungent vapors, poisonous vapors. So, we have to be alert also. We do not have to inhale these gases. You can see how delicately the two are added. The liquid part should not be added, only the gas is added to the NaOH solution taken in another test tube. Children, you can see the yellow color, that is of sodium chromate. Now we will add 2 more reagents to it, that is acetic acid and lead acetate. So, acetic acid and lead acetate, children, you get a yellow precipitate, that is of lead chromate, and it confirms chloride radical. So, very important chromyl chloride test, confirmatory test for identification of chloride. Thank you, children.